Hello everyone and welcome to today's webinar. This webinar will be run by Ewan Rule and he'll be taking us through some of the highlights of our Petrosys PRO 2020.1 release. Ewan is the sales geoscientist for Petrosys Europe. He works in Europe, Africa and Russian portfolios, and he's based in our Glasgow, UK office. Just a little bit of admin before we start the presentation. Please note that this webinar will be recorded and uploaded to the Petrosys portal in the next few days, possibly the start of next week. During the webinar, everyone will be muted, but please, if you do have a question, please submit it through the Q&A panel in your window, and I will be monitoring that. So we'll go through any questions at the end of the demo. Okay, so thank you very much, Ewan, for doing this, and over to you.
Thanks, Susanna. Hello, everybody. So we'll just start with a quick agenda. We'll do an introduction to Petrosys PRO 2020, and then we'll have a look at a PowerPoint which will show some of the key features, which we'll also look at in the live demo. I've got a slide with some additional features which we may not look at, but it's useful to know that they're there. And then we'll spend the bulk of the time on the live demonstration itself before summarising and answering any questions at the finish. The entire webinar will probably take around about half an hour. So just a reminder that Petrosys PRO 2020.1 was released in July of this year. And as you can see on this slide, we do have frequent releases. We have an agile development strategy, so you should be getting a new release every 3 or 4 months. So some of these releases have got updates to our connections to third-party systems. Occasionally there will be a bug fix, but you should also be aware that we also put new functionality into these releases. And if you can, it's good to keep your Petrosys up to date, because it really helps you get the benefit of the M&S if you get all the latest functionality available for your users. So we'll start to look at the major features of this release. In 2019, we started to work with the development kit from Ellis's popular paleoscan application. And the first thing we introduced was support for reading surfaces from paleoscan. In 2020, we can now also read well data directly and fault stick data, which we can display and also use to create fault polygons within Petrosys. So as you'd expect, both of these data types are available in mapping in the 3D viewer, as you can see in the right, and you can also use them as input for the surface modelling. Another really useful feature is a new option to convert raster grids to Petrosys grids. So this is something that many clients have asked for. It should be really useful in new venture scenarios where you maybe want to incorporate publicly available data or historical images into your project. So essentially you take your image, georeference it if it's not already georeferenced, and then there's a range of tools that can clean it up quite nicely and give you an output grid which you'll be able to use within Petrosys or transfer onto other applications. In the surface modelling, we've added in a few new options when you're working with the fault stick data. So it's quite common to have a few points of interpretation that are maybe in the wrong place. Perhaps an auto picker's moved them across to the wrong side of the fault. So there's a new option to set a clipping distance. It's just to clean up the interpretation round about the faults themselves. And as you can see, this will give you cleaner, more realistic looking fault polygons within your surfaces. And just remember, the 3D viewer is a really good way to QC this. Sometimes these things are much more obvious in 3D than they are in the map canvas. There's also a new option to set a minimum heave for the fault polygons that are generated from the fault sticks. So on the left here, you can see we've got a whole lot of fault polygons that have been produced. Most of them are closed. There's a few open fault polygons. But with the new option, if we set a minimum heave of 50 meters, you can see that all the faults are far more obvious. So this can be really useful if you want to slightly increase the the zone of deformation, or the area where you think there is some deformation from the fault, or if you want to take this grid into a basin modelling application and you need to really define fault polygons. Petrosys has been able to display raster images for a very long time, and you could also import a raster into a Petrosys grid, but you don't need to do that anymore in 2020. You can now choose a raster file as input data within display grid color fill, and it will just pick up the raster image directly. You can do the same thing in 3D, and once again you can also use these raster files as input within your surface modelling, so it just saves you a step of import. Another new feature is the ability to highlight specific contours within your map. So for a long time we've been able to highlight an individual contour level, but that would give you the entire contour, whereas now you can select exactly which contours you want to have highlighted. So this is really useful for things like mapping your contact levels. If you've got perhaps different contact levels in different fault blocks, you can set them so it's just those particular contours that you want highlighted that stand out on your map. And another new feature is the ability to display PDF files directly. PDFs are more and more common. You can either work with a single page PDF or a multi-page PDF. There are options to choose which page you want to display. If you want to display the border, if you want to make the background transparent, and you can put this onto the map itself or put it into the title bar if there is one. Now, some of the additional features include support for FMI logs. You can put them into the tracks and log signature maps. We can write check shot data back into Patrol, so that's an additional option in Exchange. We can put an individual or a group of polygons into a location map. So if we want to highlight a few license blocks or perhaps a 3D survey outline. And there are some new options for scripting polygons in the task lists. So you might want to split a shapefile of license blocks, split it up by the operator. So you can split up these GIS types based on an attribute name. And last but not least, we've added a lot more colour bars into the software, so these are perceptually equal colour gradients. So they're very good for anybody that's got issues with colour blindness. And also, because they're not rainbow colour bars, they do tend to give you a more realistic perception of your data. The problem with the rainbow colour bar is that things like the red can make features look bigger than they really are. And these have kindly been given to us by Fabio Cremeri, who's a researcher at the University of Oslo. Okay, with that we'll move straight into the live demo of the features. And I'm going to use this data set. It's actually from block K5 in the Dutch North Sea. And what we've got displayed at the moment is a surface. So it's this top hospital ground surface, it's called. But as you can see, we've also got wells and fault sticks displayed in the map. And these are coming straight out of paleoscan. So if we click on the wells layer, you can see that we've got all the normal sorts of display options you would expect. It's just another data source within our normal list. You can set top and bottom hole symbols. You can annotate as you choose, all the normal path, well path posting options, tops, information thicknesses. We can't currently support log signature data from paleoscan, but that will be coming in the next release of Petrosys PRO. Likewise with fault sticks, we're adding to the different data sources here. So you now can pick up your fault sticks from paleoscan and post them in the map too. And this can be individual fault sticks with paleoscan, or in this case it's actually a fault set. So I'm just going to switch off the grid in the background here and we'll consider these fault sticks. So what we'd like to do is turn them into fault polygons and use them in Petrosys surface modelling. One issue we have with the surface that we have displayed here is that it doesn't actually have any fault polygons within it. So we'll create our own surface. And to do this, we're going to go into the surface modelling. Now I've set up one of our task files here, and I've created 3 different grids. The first one is just using Petrosys normal options. But we'll just have a look at the third one. The second one has got the minimum heave introduced. The third task has introduced the minimum heave and also the clipping distance round about the faults. So to see these options, if you go to the faults tab, scroll down to the bottom, you'll find this option here. So this is just saying clip the input data 200 meters away from the faults that we're going to generate in the map. And then the minimum heave, that's saying give us a minimum heave of 50 meters. So in both cases, it's working in map units, which in this case will be meters because we're working with a UTM projection. Now I'm not going to run this task live because these options do slow it down very slightly. But what we'll do is we'll have a look at the outputs from these 3 tasks and just compare the grids. And we'll do this in our 3D viewer. So this is the grid that's created where we don't have any clipping of the faults and we don't have any minimum heave set. So it's not done too bad a job, but you can see a lot of the faults are really quite small. And also in these main faults, you can see this should probably really be a fault surface too. It does look quite untidy as we go along it. So by adding in the minimum heave, you can see that the faults all get a bit wider, a bit more obvious, and it has improved things along this fault here. But if we do a little bit of clipping to the input data too, and then just interpolate back up to the fault, you'll find that you get these much cleaner, much better looking faults produced within your map. So you may not want to do this all the time, but there are additional options that are available to you as an interpreter. And if you have any issues with the quality of your interpretation and want to tidy it up quickly, these are some easy ways to do it to limit the amount of time you might have to spend in the spatial editor just getting things exactly the way that you want. So we'll return to our map. And I've got those 3 grids that we created in the map here as well. We'll just turn on the one that is the best quality and we'll switch off our faults. So if we have a look at this grid and we go to the colour gradients, you'll see that we've got all these new perceptual colour gradients applied to us by Fabio. And I'm just going to pick up this Jolla inverted one and we'll use that to display the grid. So that's correct, we've still got the high down to the southwest here. I'll put some contours on here and then we'll look at how we can highlight some individual contours. So this part is just a normal Petrosys functionality. And we might be aware of a few different contact levels. So we'll do what we've always done if we want to highlight something, put in a few additional single contour levels. And I'm actually going to make these blue, which should stand out quite well. So you can see the additional contour levels are now highlighted in blue. This is just what we could do before. But if we zoom in, we might decide that we want to have different contact levels. So perhaps here with this 2689 contour, we want to highlight this one. If you select it with the left mouse button, you can then do the right mouse button and choose Apply Contour Style. And in this case, we don't want 2689, we want 2683. We'll just repeat this process, Apply Contour Style. Now, when we go back to our display panel, you can see the highlighted contour style is this darker blue. I'm going to change that to green. And we'll mark this as our oil-water contact. And the last thing I'll do here is we'll switch off the single contour levels, and then these won't be drawn across the entire map, just the actual highlighted ones. So there we go, we've now got oil water contact there at 2683. And if we wanted to, we could of course use the overpost correction to put a label onto this contour too, which is indeed at 2689. So different contact levels and different fault blocks, just to give you a map that shows exactly what you want. It's also a good reminder of how choosing a different colour gradient can sometimes be quite nice, because in this case the green stands out very well against a sort of reddy brown background. A few more things, we'll just add in a PDF file. So of course you can go to display menu here, display PDF, but you'll also find this new button. So this one here is to create a PDF, this one is to display a PDF. So obviously you can choose PDFs from wherever you have them stored. This is just one from Netherlands Oil and Gas. You can change the page number and you'll get a little, select it again, closed it down. You'll get a little preview of what is currently being displayed. We'll just go with this first page. If we chose to, we can make the background transparent, we could switch off the outline and so forth. And then you can decide if you want to have it displayed, got it selected twice. You can decide if you want to have it displayed within the map area for usual positioning options, or if you want to put it in the title bar, which is what we'll do just now. So we'll just zoom in on the top right here. And hopefully you can see that the quality of the PDF, the rendering of the text and so forth is very good. It's much more legible than it would be if you'd just taken a screenshot of it and pasted it in as a raster image. But the other thing I want to point out is we've got one of these custom location maps up here. So the red box is the outline of our map with a WMS showing us where it is in the Dutch sector. But we've also chosen to have some field outlines displayed in here just to orient us a bit more in the location map. The final thing I'm going to do is display a raster image directly. So if we go to display grid, choose display grid color fill. In your data sources, you've got Petrosys and all the usual interpretation systems. We added in rescue files in the last release. You'll also find raster file here. And I'm going to choose a Jebco bathymetry grid. It's good quality bathymetry data that I've downloaded online. And we'll choose a different color bar here. So once you get familiar with these color gradients, there are some quite nice ones. I think we'll go with this one here called Oslo. Won't bother contouring it just now, we'll just put the raster itself onto the map. So there we go, this is coming straight from the raster. You can see we've possibly got some lines where the data was acquired, but it's more useful information that we can include in our project. And we'll just send that down to the bottom of our list. So there we go, we've got some quite nice new features in this version of the software, the PDF, the location map, the highlighted contours, the new colour gradients and the clearer faults. The other major feature which I mentioned in the introduction and we've not looked at yet is the option to convert a raster file into a grid. So I'll go to a different map. So I have been through this process with this, but we'll just show you how you can do this if you wanted to give it a try yourself. So as you can see, I've got a raster image here. There's some sort of grid. It's a 16 thickness over a large part of the Dutch sector. The first thing I did was just digitise a polygon round about the area we're interested in, just using the spatial editor. I only did that just to constrain the gridding when we come around to creating a grid from this. To work with the image, do a right mouse button or open the spatial editor, click and edit. Underneath operations, we've got this new option, create grid from raster. So we'll try and guess roughly what area you want to include in the grid you're going to create. You can obviously adjust this if you want to, but I'm quite happy with it, so we'll go with that. And then we've got a fairly typical looking Petrosys panel with a series of tabs that we'll work through to generate our output grid. And in the right, we'll see some previews of the image, so you can see the image at various stages. So here I've selected my polygon file just to constrain the area we're going to grid. Obviously, you've got access to all the different polygon sources that we have. We can also do some image masking. So if I go to the edit button, you can see that I've already done this. I've got an editing circle. Anybody that's used the spatial editor will be familiar with this idea. You can make the editing circle larger or smaller, and essentially all I did was rub out the things that I don't want, things like the scale bar and the legend. So of course we could revert this if we want to and do it all again, but we'll just cancel out of that because it's already done. When we click on the mask button, you'll see the effect of this. This is what we've got left, which we're going to work with and convert into the grid. So now we move on to the image pre-processing. There are various different techniques you can add here, things like blurs and morphology. Just to give you an idea of what these different things do and how they've been set up. Essentially, I've used the colour picker to move on to part of the map where I want to remove something. These are actually dikes that are displayed in red. So all I did was take the colour picker, drop it on there, and essentially I'm saying I want to remove these pixels that are red from the image we're going to use to create the grid. These aren't part of the actual grid. And we've done the same thing with the blacks for the boundaries and for these sorts of greyish colours, which I think are the block boundaries. And the morphology option, it just lets you, once you have a look at the pre-processing, the morphology option lets you open things up a little bit more. So if you think you're not getting enough of the pixels from the block boundaries, you can just open up a bit more and take a few more out. So essentially this is where we've got to from setting up these pre-processing options. The next thing we want to do is extract the values. So you need to have some way to calibrate your image. If we go back to the source image, you can see that we've got the legend here. So this works the same way. We can add in a new Z value and use the colour picker to pick an individual colour off here. Now, sometimes you might find that it's better to just do it straight off the image itself. So we could just take the colour picker, try and find an area where it's really dark blue, which should be a value of 0. And just drop it in there. And then you can also save your colour gradient if you want to. You don't have to do this, obviously it's going to become a grid and you can use all the normal colour gradients. But if you want to make it look exactly like your image or as close to as possible, you might want to do this option too. And then we come to the output grids. All the normal gridding options here, we just need a name, a coordinate reference system. In this case, the area of interest is likely to be defined manually, just from this pink box. But think about your cell size. Other than that, it's pretty straightforward. And we can just go ahead, give it a try, and create this grid. So I'm actually just overwriting an existing grid here, and we'll see what it looks like. So when it's finished in the spatial editor, we can go back to our map. This was our initial image. If we switch this off, we've got our grid that we've created here. It should have the colour bar that we saved. And when we switch this on, this is the result. So this was done pretty quickly, and I'm sure it could be improved on with a bit more time, but already we've taken an image and we've got something that's usable and we can work with within our surface modelling. Could be a regional surface. We could start improving in this, merging in better quality data. We could write it back into Petrel or save it out as an ArcASCII file. There are other things we could do to improve areas like this, where you can see we've still got some effects from the block boundaries. But overall, I think it's done a really good job. And that essentially concludes our demo of the new features in 2020. I'll just go back to our PowerPoint and we'll finish off with a quick summary. So 2020.1 is a major release, and that means that new license keys are required, so you will need to install new keys. However, there aren't any file or project upgrades required, so there's no reason not to go ahead and install it and start having your users working with this version. The raster to grid feature has been driven by user requests. We've had a lot of requests for this over the years. I'm sure we may add functionality as we get feedback on it, but I think in many contexts it will do a very good job and be a big time saver. We've got significantly more functionality in the paleoscan link, and we will be developing this further. And we're also supporting more data types directly, so direct use of the PDF files, direct use of the rasters without having to import them into the grids. And of course, the mapping is one of the key features of the software. Highlighted contours, new color bars. It should be even easier to make really good looking maps that do everything that you want them to. So just a reminder that if you click on the Petrosys PRO button on the main panel of Petrosys, it will open up a web page for the Petrosys portal. This has got a whole lot of PDFs and movies, and it's been rearranged fairly recently so that it follows workflows. So it's a really good resource for anyone that wants to look things up for themselves. But I would just like to close by asking if anyone has any questions about the new release.
Hi Ewan, thank you very much for the presentation. I've been monitoring the Q&A panel whilst you've been going through the demo and workflows, and I've got a question about the raster to grid tool. And someone's just asking how much manual editing is required when generating these outputs. So really how accurately the output grid is in most cases.
That's a very good question, and the answer is that it depends on the quality of the input image. So if you've got a clean input image, if it's got a well-defined gradient, if it's got a good colour bar to calibrate it against, it can be quite quick, especially if you don't have a lot of text or other things that you want to remove. So while I was testing this, I had another image which really worked very well and very quickly. Obviously, the counter side of that is if it's a slightly grainy image, if you do have a lot of text, then yes, it is inevitably going to take a bit more manual intervention to tidy it up. One of the things we're going to do with clients is invite them to have little sessions where we can just maybe go through an example with them and show them how these tools work. But I've been really surprised about what a good job it is doing. Last point I'd like to make about that is just to remember and manage your expectations, because taking something like this, there is likely to be a slight level of inaccuracy, but it's going to give you something that you can work with, which in new ventures is going to be really useful.
Thanks, Ewan. Yep, that makes perfect sense. And the second and final question I have is about our display PDF functionality, and we just have a user who's asking whether we support GeoPDFs and whether they're correctly positioned on the map.
So again, a good question. At the moment we don't, as I think the users know, when we produce PDFs from Petrosys, we are geospatially aware. At the moment, no, we're just putting it on interactively, just placing it onto the map. However, we're continuing to work on this, and I think in the next release of Petrosys, it will support georeferenced PDFs automatically, so you won't need to position them. They'll be in the right place straight away.
Okay, that sounds good for future development. Thanks, Ewan. Yep, that's all the questions here from my end.
Thank you, Susanna, and thank you to everybody who attended today. I'm sure you're going to enjoy working with Petrosys PRO 2020.1. Please get back to us at support or to myself if you have any questions. We'd also like feedback and suggestions about what we should be doing next. Thanks again, everybody, and enjoy your day.